Beautiful. So now that we've got our environment set up, we've got our Jupyter Notebook running, or a Jupyter Notebook server running, we can create a new Jupyter Notebook and get started on some code. So let's load that up. I'm going to maximize this window. So we'll give it a name here. We'll go end-to-end, something nice and simple, end-to-end heart disease classification. And in good communication style, we'll put a markdown heading and go something simple, predicting heart disease using machine learning. And then a little one-liner. So this notebook looks into using various Python-based machine learning and data science libraries, which are our tools, in an attempt to build a machine learning model capable of predicting whether or not someone has heart disease based on their medical attributes. Whew! So that's probably more than one liner. We could probably concise that a little bit, but that's not our focus. Our focus is writing code and applying it to the framework here. So this is what we want to work through. This is what we're starting to do. We're starting to apply the tools that we've learned to our machine learning framework in the scope of a full-blown end-to-end machine learning project. Oh, I hope you can feel the excitement. So, how do we start off? Well, the first thing is probably good to outline our approach. We're going to take the following approach. So the first step is problem definition. We've kind of done that with the opening line. So problem definition 2 is data. We'll look at what data we're going to use to work through this problem. We've kind of already seen it in previous videos, but again, for completeness, we'll just have a little overview look at it here. Then we'll go evaluation. We'll define quickly what an evaluation metric means for us, like what defines success. For this, if we were to deem this project a success, this machine learning proof of concept, could we predict heart disease using machine learning? What would we need as an evaluation metric as a bare minimum? Features. So what features of the data are we going to be most focused on? And even which contribute most to the model, which is step 5, modeling. And finally, step 6 is experimentation. And realistically, the whole thing is experimentation. So this is what we might start with. And again, if you're quite experienced here, you might just start diving in straight to the code. You might know what to do. But for us, because we're still learning, we're still figuring out how to approach different problems, we set up this framework and then we figure out how we can use our tools at each different step. So let's go back. First and foremost, problem definition. We've kind of already done it here, but in a statement that we could tell someone else. So in our case, we're doing binary classification, so whether someone has heart disease or not. So there's only 2 classes. Remember, classification is predicting whether something is one thing or another. So in a statement, we want to, or we'll put it in a nice little quote. So given clinical parameters about a patient, can we predict whether or not they have heart disease? Wonderful. And then 2 is the data. Now, if we come up here, we know that our heart disease data is in a CSV file already. And if we click on that, it's going to load up. It's pretty hard to read here, so that's why we're going to import it soon using a pandas data frame. But if we go up here and if we go UCI heart disease data set, this is where we find about, and this is step 2, by the way, data. This is where we're finding out a little bit more about what data we're actually using. So this is where you could come and download it from. This is the original source for it, the UCI machine learning repository, which has a lot more different data sets in here that you can kind of work on and use for example problems like what we're working through. But to get it in the CSV format, it's already been formatted, and that's on Kaggle. Now you can go to Kaggle as well and get a lot more different data sets. Over here, it's got a little menu. It's got data sets there. You can even search for different things. But this is where I came to originally at this data set. You can download it here. So if you click download, it's going to tell us a little bit more information about the data, some attribute information such as what the different columns stand for. If we keep going, We look here, we see that the different columns, this is where their different values are. So what this is a data dictionary. And we're going to see this in a second. This will come in handy. What we might do actually is see if we can copy this and take it back to our notebook. So this is a data dictionary. So we might go here, create data. This is getting a little ahead of ourselves. So if we go there, boom, that's what we can use to reference what the columns are in the data. So if we go here, data, we could probably pull out something from here. So if we copy this, so this database contains 76 attributes. Well, actually our data set only contains 14, but then we read here, but all published experiments refer to using a subset of 14 of them. Okay, wonderful. And so then if we went back to the UCI heart disease data set, we get a little bit of information here. So only 14 attributes used. Now you won't always do this for every project that you work on, especially if you're working within a company or within a team. The data set might be given to you by a customer or by a client. But for the problems that we're working on, because we need access to open source data, that means data that everyone has access to, we can find them publicly on the internet. But then again, the process is very similar no matter what data set that you're working on. It's all about getting it in the right format that you can work with it in your Jupyter Notebook. We might put in here the original data came from the Cleveland database from UCI machine learning repository. There is also a version of it available on Kaggle. And so what you might do is copy that in there. Beautiful. And we'll also copy that in there. And we could tidy this up later, but this is just some information about the data. Where did it come from? What data do we have? And so we go here, number 3, evaluation. So if we were actually working on this project, we wanted to implement this. Let's say we were a hospital who wanted to be able to implement this as a machine learning model, as an application on the front desk. If someone comes into us and we're a nurse, we're measuring these different parameters about them. So we found out different patient attributes. What metric would we need to judge our model as being effective, as being able to use in play? So if we're trying to classify whether someone has heart disease or not, because that's pretty significant, we'd want a very, very accurate model. And so, for example, I'm just going to make a number up. So you might say something like, if you can reach 95% accuracy at predicting whether or not a patient has heart disease during this proof of concept phase, which is kind of what we're working through here, then you might pursue and try to really get into the hands of other people. So that's the essence of what we're going to work through here, is we're building a machine learning proof of concept. The reason why I say proof of concept is because oftentimes machine learning projects will start out as trying to figure out if there are even enough patterns in the data to be learned by a machine learning model. And if there are, then you might pursue the project further and get it into production or into some sort of application. So again, this is just another benchmark we might set ourselves as a goal to work towards at the very beginning of a project. And it's not set in stone, this may change. It's just something you might reflect with your team, like, hey, if we're going to spend 2 weeks working on this machine learning project, what figure would we have to end up with for it to be pursued more? So let's do that. So if we can reach 95% accuracy at predicting whether or not a patient has heart disease during the proof of concept, we'll pursue the project. And this may be another thing, right? Someone might come to you at a data science company or something like that. Someone from another team might go, hey, we've got this data set. We want to measure how many of our customers are churning. And we want to see if we can build a machine learning model to help us out. And then they may say, hey, do you want to work on a proof of concept like similar to what we're doing here? And this is how you might set it up. You might start out by going problem definition, figure out if a customer is going to churn or not. Where does the data come from? It comes from our customer database. What's our evaluation metric? Well, if we can figure out if a customer is going to churn at about 80% accuracy, then we might keep pursuing this and actually get it into our production pipeline. That's an example kind of workflow of the first 3 steps. And then finally, step 4, well, not finally, we've got a fair bit more to go. features. So if we come back, so we've done this, we've done evaluation, what defines success. We go, what features should we model? This is step 4. So this is where we're creating a data dictionary. And what I mean by that is you may be able to create this on your own by doing a little bit of research. So we might put this in bold. And again, we could tidy this up by putting these all in dot points, but they'll start to make sense in a second once we actually see the data we're working with. Actually, yeah, we might type this into, turning this into dot points. So now we've created our data dictionary. This is something that you may find through your own research, like we've done here, finding out about the data here, finding out about the data, or you may create it with the help of a subject matter expert. And what I mean by that is, say for example, you had that team come to you with a whole bunch of customer data on who's going to churn or not. Churn meaning that they're going to leave or stop using your product. And they may tell you what different features of the data mean. And so we'll put here, this is where you'll get different information about each of the features in your data. So essentially, when you start to work with the data, you won't be a complete novice. You'll have some idea of what's actually going on or what each section of the data means. And this will make a lot more sense when we look at our data in the flesh, when we import our heart disease CSV file into our Jupyter Notebook, which is what we're going to do in the next video. So these first 4 steps, 1, 2, 3, 4, problem definition, data, what data do we have, evaluation and features, don't necessarily have to take that long. So we've just gone through all 4 of them in about 10 minutes because what we want to do is get hands-on with the code and let the code and data speak for itself rather than trying to just think about it here. We want to see it in action. So that's what we're going to do in the next few videos.